Understanding Ethereum Gas, Module 1, Video 7. Gas quantifies the computational effort required to execute the required operation. For example, if I want Ethereum to compute 4 plus 4 or even send a message, it will require me to spend some gas, or we can call it transaction fee in layman language. These transactions cannot be executed without specified gas amount. So, as we have discussed, it is like a transaction fee which incentivizes miners to validate and process your transactions. It also helps in preventing abuse like spamming by making expensive or rather complex operations costly. Gas also ensures efficient allocation of network resources such that there is no overuse. So, before getting to how gas works, we need to know that total gas cost is equals to the amount of gas units used times gas price of a unit. When we are making a transaction, we need to specify a gas limit and set a gas price. And then the miner processes the transaction and charge gas fee. But what is gas limit and gas price? Gas limit is the maximum gas units you are willing to use for your transaction. Note that the gas used in the end may be less than the set limit. Gas price is amount of ether to pay per unit. Higher the price you set, faster will be your transaction. So to sum it up till now, we set gas limit and price according to our convenience. Miners process the transactions using their computational resources, and then the gas fee is calculated and paid to the miners in Ether. We can also understand Ethereum gas using a fuel analogy. Gas is the fuel that powers Ethereum transactions like fuel powers a car's engine. You set a gas limit to prevent overspending. You set a fuel budget to avoid running out. The gas price determines how quickly your transaction will be processed, while paying more for premium fuel can improve your car's performance. Now, we have already discussed its similarities with service fees, and the same can be seen here. Gas is a fee paid for using the Ethereum network. Service fees are paid for using a service or product. Higher gas prices means prioritizing your transaction, while higher fees can get you a faster or better service. Gas prevents abuse by limiting resource usage. Fees discourage excessive or inappropriate usage of services. Another interesting analogy I came across is of an amusement park. Let's say Ethereum blockchain is an amusement park, rides are transactions, and miners its operators. Now the operators need electricity to run the rides. But electricity is not abundant, and so if people just come in, it will cause an issue. Therefore, everyone has to have some amount of tickets, and each ride has a fixed cost. These tickets are then taken by miners as their fee to process transactions, or rather in this case, run rides. Hopefully this helped you understand how gas works and why we need it. We can budget for gas by determining the maximum gas budget. We can choose how much to pay per gas unit, which will determine the time taken for our transaction. If gas use exceeds the limit, the transaction fails. And as we discussed, the gas fee paid is gas used times gas price. Another analogy can be made between gas fees and taxi rides, as you can see here. Let's say you need to prioritize your transaction. You can do so by increasing your gas price. Miners would obviously want to process transactions which pay them more first, and hence, higher the gas fee, less time it will take for a transaction. But how can we set the right gas price? We can estimate gas needs using tools which can determine how much gas is required for our transaction. We can set a limit high enough to cover costs but not too high to avoid overspending. We should always consider the gas price, as higher gas price results in faster processing but higher fees. The gas prices should be adjusted based on the current network usage and congestion. Gas is also required to deploy smart contracts to the network. Calling some functions within a smart contract which updates the contract state consumes gas. The more complex computations require higher gas. Gas is consumed for transactions which includes simple transfers like sending ether between accounts, contract interactions where functions consume gas, and data operations as changing data in blockchain uses gas. Any gas not used in a transaction is refunded. Removing data from storage provides a partial gas refund. These refunds encourage optimizing gas usage in smart contracts. The relation between gas price and network congestion is as follows. When network is not congested, lower gas prices are accepted. On the other hand, as usage increases, transactions start competing for block space. To get priority, users must offer higher gas prices to miners. Once congestion decreases, lower gas prices become viable again. In summary, gas represents the computational effort for executing transactions. It prevents abuse by making operations costly. Gas fees incentivizes miners to validate and process transactions. Gas also ensures efficient allocation of network resources and bandwidth. For any further doubt, feel free to reach out to us on our server. Thank you.